table, and what is the other one? Concurrent hash map. Okay, so last class what we have discussed, both are synchronized. Okay, both are synchronized, right? Okay, now try to understand. It depends upon the way how you are synchronizing your data structure. Okay, so now try to understand what happens is hash table. Suppose I am having a hash table and it will have always two methods, put, get. These are the usual method which both will have, right? So let's discuss about hash table first, then we'll go to concurrent hash map. Okay, so in hash table what happens? What is synchronization? Synchronization means only one thread can work at a time. Multiple thread cannot work. Okay, so now suppose there are two threads, T1 and T2. So there are two threads which are working, T1 and T2. Okay, so if you are working with hash table, then what will happen? Suppose T1 is working on put. Which is a thread? T1 is working on put. Now this T2 cannot do this one also, and this one also he cannot do. Why? Because it is synchronized, right? So synchronized means only one thread can work at a time. I mean, if T1 is doing put, then what will happen? You cannot do get. I mean, any other thread will be locked basically. Okay, so when T1 is over, then he will be eligible to do this, both of those. If T1 is not over, then T2 will have to wait for some time so that T1 is over, then T2 will come and he will start working on those basically. Got it, right? So the synchronization will be on your object level. Object level means until unless one method will block full our object only. So if T1 is done, then only T2 will come into picture. Okay, but concurrent hash map will have some sort of different scenario. Okay, so suppose I am having same scenario here also in concurrent hash map. Concurrent hash map. Then what will happen? Try to understand. Suppose T1 is doing put. Okay, then T2 cannot do put, but get he can do. I mean, T2 can do get. Are you able to understand what I am telling is? This is also synchronized. It's not like it is not synchronized. The synchronization will be in your method. I mean this method, because T1 has locked, so only T2 cannot do this, but this is free. But in this case, in hash table, what will happen? Both will be locked. Got it, right? So if T1 is working on put, T2 cannot do put also, get also. When T1 is over, then only T2 will be able to work with any of those basically. Okay, so this is the difference between your hash table and concurrent hash map. Now tell me, who will be fast, hash table or concurrent hash map? Concurrent hash map. Why? Because T1 is blocking only this one. This one is free for you. But in case of hash table, both are blocked. So it will take more time to execute, right? Definitely. Okay. So that's why. So which will be fast? Concurrent hash map will be faster than your hash table. Okay. So what we understood here is we have to go off little early. So okay. So maybe we can have 10-15 minutes class. Okay. So now try to understand what is the difference between hash table and concurrent hash map. So hash table Okay, so difference lies on the way of synchronization. Okay, so the way how we do the synchronization, there the difference is both are synchronized, we know, right? So both are synchronized, but the difference lies on the way of synchronization. Okay, so in hash table what will happen? In hash table, if any of the thread is working with any of the method, or maybe suppose we will take the example of put. Suppose any of the thread is working with put method, then what will happen? A whole object will be locked until and unless put is not over. Okay, when put is over, then only he will be able to other thread will be able to work with it. Okay, so even other thread can't do get also. So get is also locked. So get, other thread cannot do get also, other thread cannot do put also. But in case of concurrent hash map, only put method will be locked. Put method will be locked. Other methods will be eligible for invocation. What I am saying? Okay, so in hash table, if you are doing one task by one thread, then other thread cannot do anything. He will be locked for all the operation. But in concurrent hash map, what will happen? The operation which is getting done by one thread will only be locked. All the other things will be as it is. Other thread can work as it is normally. Okay, so this is your first difference. What is the second difference? Tell me, who will be fast? Concurrent hash map will be faster than hash table. Why? Because hash table is locked. Other people not able to do anything. But in concurrent hash map, something will be open for the other thread to work on, right? So concurrent hash map is faster than hash table. Okay, so this is the one. Now we will just discuss this interview questions, then we will finish it up. Okay, so tell me, what is the difference between single equal to, double equal to, and equals method? Single equal to is for assignment, double equal to is for comparison of primitive data type or reference comparison. Okay, and what is equals method? Equals method is used for the meaningful equivalent. Okay, so if both are exactly same, then only your things will work. Okay, now can we use hash code for equality purpose? No. Okay, we cannot use. Why? Because if hash codes are same, so as I had given you one of the example. Okay, so if you are here, okay, and some other guys in some other batch, then both of you might have the same roll number, right? You never know. Okay, so if you are having roll number 2, some other people is having roll number 2, so both of you are same? No. Are you able to understand? So similarly here also, hash code we can never use for the equality purpose. What is the best way to use? Equals method. Okay, so we have seen the pseudocode for equals also. So in pseudocode what happens, equals method will first check hash code. If it is same, then it will go internally and do the bitwise comparison, and then it will check the equivalency of both of those basically. Okay, now what is the difference in collection and collections? Collection is the interface, collections is a class. What type of class it is? It is a utility class, and collection is a super interface, okay, which is on the top of all our whatever interface we are having. Okay, yeah. And set versus list. Set does not allow duplicate data, list will allow duplicate values also. So if we'll ask Tarun, hey, give me the list of students, set will have all the duplicate names and duplicate registrations, but list does not have duplicates. Okay, yeah. How HashMap is implemented internally? Okay, I'll share one blog, you can go through those basically. So internally it is very important question. Okay, so we're going to discuss while going through. It usually use one of the bucket structure. Okay, so where all the entries will be there. Okay, so we'll discuss while going through. So which all are synchronized collection? Vector, then hash table, then concurrent hash map. And if you want to make your set synchronized, how will you do? Collections dot synchronize set, or synchronize something will be done. Okay, so this is the way how we will do. Now difference between array list, linked list, and vector on the basis of insertion, deletion, searching, memory. Which is the fastest? Array is the fastest. Who is the slowest? Vector is the slowest. Now among those two, who is fast? Depending upon the operation. So if I am doing insertion, who will be fast? Linked list will be fast. Why? Because only 2 nodes will be affected. Okay, in case of array list, you are having rearrangement of your index. That's why array list will be slow in insertion. Okay, if you want to delete linked list, again only 2 nodes, you just cross that, just have the mapping, that's all. Okay, and in terms of searching, who will be fast? Array list will be fast. Why? Because you are having index, you directly go to that jump, you can directly jump and get the data basically. Okay, and memory utilization will consume more memory. Linked list will consume more memory. Why? Because it is having 2 nodes, it is taking care of 2 nodes, but array list no nodes, it is having only one index, that's all. Okay, so that's why your array list will be fast in terms of searching. Okay, null key, null value pair in HashMap, TreeMap, and hash table. Tell me, HashMap, does it support null key? Yes. Does it support how many null keys? 1 null key. Okay, because we don't have hashing. Yesterday I forgot the thing. Right? Hashing collision. Okay, in your C, you might have studied this hashing collision, hash collision. Okay, but in Java there is no hash collision sort of thing. Okay, so what we do is we directly overwrite the data on it. So there is no two keys having the different data. Okay. So HashMap will support 1 null key. Okay, null value I can have n number of. There is no restriction. Okay, so I can have many null values. Then TreeMap. Can it support null key? Can it support? No. Why? Because TreeMap will sort the data based on the key, and you cannot compare null with any other data, right? So TreeMap does not support null key. Can it support null value? Yes, I can have multiple null values, no problem at all. Why? Because TreeMap is not sorting based on the based on the value. It is sorting based on the key. Okay, so only we can support many null values in TreeMap. What about hash table? Can we support null key? No. Can we support null value? No. Okay, why? Because whenever you do synchronization, right, so that time you have to compare your data. And while comparing, null cannot be compared with any of the other data, right? So that's why hash table or concurrent hash map both will have, we can never have null key. Null value is also not possible. Okay. And which all are sorted data structure? Tree. Wherever tree is there, all are sorted. Okay. So on the top, tree set is sorted. Then tree map is sorted. If you want to sort list, how will you do? Collections dot. Okay, collections dot sort. You pass that list, automatically it will be sorted. Okay, yeah. And comparator and comparable. So we have not discussed this. Okay, so try to understand when we use comparable and comparable. We'll just discuss for 5 minutes, then we'll finish. Okay, now I will give you a very simple example. Okay, so I suppose 3 67, okay, 21 43. So I'll tell you, please sort this data. Please sort this data. So how will you sort? How will you sort? Yeah, so something like 3, then 21, then 43, then 67. Very simple. Okay, now so it is very easy to sort if you are having only one data. Okay, now suppose you are having one of the class called animal. Okay, animal having many things, number of legs. Okay, it is having name also. Okay, it is having name also. Okay, it is having some sort of maybe anything, it can be possible, right? Animal, what all properties will have? Color also. So there are 3 properties which are there in animal. Okay, now I have created 3 objects. Okay, so one is animal 1 object, animal 2 object, animal 3 object, animal 4 object. Now sort those animals. Can you sort those animals? You cannot sort. Now you will ask me, based on what I will sort? Do you want to sort based on legs? Do you want to sort based on name? Or you want to sort based on the color? Are you able to understand what I am talking about? Okay, so if you are having one data, it is very easy to sort 1 2 3 4 A B C D E F G H. Okay, but if you are having more than one data inside your object, object will have name also, object will have your many things. I mean okay, so you need one criteria, right? Based on that you want to sort all those data. So comparator and comparable are the way by which they can give you the criteria, whether you want to sort based on the number of legs, name or color. Got it, right? So this is the way how you can do this. Okay, so let's try to do a very simple example. Okay, so maybe within 5 minutes. Okay, then we'll wrap it up. Okay, so suppose we are having one of the class called animal. Animal is your class name. Okay, animal is your class name, and animal is having something like in number of legs. Okay, then what is the another one? Tell me. String name. Okay, then int color. Okay, we can have getter status alt shift s, select all. Okay, okay, this is your animal class. Okay, now we will create one comparator. Okay, so let's create one class called comparator. Okay, so comparator, we will give the name called comparator class. Okay, extends, Are you able to see somewhere comparator or something? Why it is not coming? Huh? Do I doing some spelling mistake or something? What is not coming? Let's see. Okay. So okay, sir, it is implements here. I'm really sorry. Okay. So implements comparator. Are you able to see here comparator? So what data you want to compare? You want to compare animal data. Okay. So I'll pass here as my animal. Got it, right? And I'll implement that method, the one which you want to do this. So now based on what you want to compare, you have to return here. Okay. So suppose I want to compare based on the name. I mean, if animal name is dog and horse, who should come first? D should come first. So dog will come first, then horse. If you want to compare based on the number of legs, that also you can do. If one animal is in number of like 4, he should be first, then 5, 6, 7, something like this. Okay. So suppose based on the name I want to do, then how will you do? We have to do like this: O1 dot get name dot compare to. Okay, you pass this O2 dot get number of yes. Compare to or compare? Wait, there is some problem with this. Okay. So this is one of the way. Okay, you can do something else. Let me check first. Okay, compare. Sorry, I forgot the syntax. Okay. So what is there? See, O2 minus. Okay, so okay. Compared to, same, I was writing correct, right? Compared to, why it is not getting this? Compared to dot get name. Yeah, right. Same only. Why it was not working earlier? Interval. I written the same, right? Okay, let it be. Whatever things are okay. So what it will do is it will compare based on the name. If one animal is having name called dog and another animal is having name called horse, who will come first? Dog will come first. D will come first, right? Okay, so let's try to go and write this example. So we'll go to our main class. Okay, so let's try to create one list of animals. Okay, first we'll create animal. So suppose animal. First let's try to create the list of integers. Okay, list of integers equal to new array list. Suppose the one is your array list. Okay, so integers dot how to add the data. Add is the method. Okay, suppose 90. Okay, similar to this, if we'll add the data, some sort of data we are having. Okay, so something like 23. Okay, then 1, then 6, then 21. Okay, if you want to sort those data, how will you do? Collections dot sort. What you want to sort? Integers. So integers. Now if I'll iterate, what will happen? The data will be in your sorted order. So let's try to sort. I want to show those data. SYSO integer integer. Now what should be the data should come? 1, 6, 21, 23, 19. Okay, so because we know the order of those 1, 2, 3, 4, whatever the orders are there. Okay, but suppose, as I told you, this is the way how you will sort your integers. Now suppose I will tell you, please sort animals. So suppose animal equal to new animal. Okay, so similar to this you will create many animals. Okay, 1, 2, 3, 4, 5. Okay, here animal dot set name. Suppose name is anything, okay, similar to this. Suppose here also we are having all those names, different names are there for animals. Okay, suppose his name is dog. Okay, his name is horse. Okay, his name is maybe anything, tell me, cat. Okay, then lion. Okay, then we are having tiger. Okay, so here it should be 5, it should be 4, it should be 3, it should be 2, it should be 1, because we want to set all the places, right? Now if I'll ask you, please tell me, I mean, who is greater, which is smaller? Do you know any can you compare? You cannot compare. Now what will help you out to compare? Comparator or comparable. Got it, right? Because the comparator which you have created, what it is comparing? It is comparing the name. Okay, now let's try to do this example. So how to do? Very simple. I want to create the list of those, so we'll do this list of animals. Okay, animals equal to new array list. Got it, right? Now keep on adding all those animals dot add animal 1. Sorry, first one is your animal. Okay, then you want to add all the animals, 2, 3, 4, 5, 6. Okay, so animal 1, then 2, 3, 4, 5. Got it, right? So we have added 5 animals. Now if I'll do this, will you be able to get, I mean, which animal is coming first? You will not be able to find. Why? Because you don't know the order, right? So suppose if I'll do some sort of, see here, if I'll do collections dot sort, if I'll pass animals, see what is happening? Is it supporting? It is not supporting. Why? Because he found that this is not your integer, it is not float, it is not your string, it is a POJO class. Got it, right? So now it is waiting for some criteria, and who will give you the criteria? Comparable or comparator. Okay, so very simple, we already created the class, right? So you can just use this comparator class equal to new comparator class, where you have already defined the criteria. Okay, and just mention over here is your second parameter. That's all, over. Now what will happen? This collection will sort this based on your names, because in your criteria you are mentioning the names, right? So let's try to see whether it is sorting or not. Okay, so here if we'll do SYSO, okay, you get the name of those animals. So animal 6, right? Why? Because this is the animal 6 from where you can get the data. For loop, right? So left side will be your assignment. Okay, dot get name. Now let's try to run this code. Who is coming first? See, A is coming first, then cat is coming, dog, horse, lion, tiger. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. Got it, right? So but if I will not use it, in which order the data will come? Data will come in the insertion order. Why? Because it will take care of index, right? So A, then dog, then horse, then cat, then lion and tiger. Okay, so let's try to see the output. A, dog, is it sorted? Not sorted. Okay, now if you want to sort, you have to define the criteria and it will come here. Okay, so let's try to see. Now it is coming in sorted. A, C, C, C. Suppose I want to do the sorting based on the number of legs, then what change I have to do? Tell me. Here only. Okay, so integer first leg equal to o1 dot get number of legs. Okay, similarly you have to get the second number of legs, second leg will be your o2 means second animal, right? You are comparing both of those. Okay, and instead of this, what you do, you write here first leg compared to second leg, that's all. So but one small thing you have to think about is this comparative supports only this object, it will not support the primitive data type. I could have done like this also, right? Int first number of leg, int second number of leg, it will not support, it will always support your wrapper class basically. Okay, that's why I am converting it into your wrapper class. And how it will be converted? Auto boxing, we already know that auto boxing, it will automatically be converted, no need to do anything. Okay, so yeah, now based on what it will compare based on the number of legs. So we don't have number of legs, right? So let's try to put some number of legs here. Okay, so suppose I'll do animal dot number of legs, animal dot set number of legs, suppose 3. Okay, so suppose he is having one leg. Okay, he is having 1, he is having 2. Okay, maybe he is having 7, maybe he is having 0. Okay, maybe he is having anything, 90. Okay, then we have to pass those change also 1, then this is for 2, this is for 3, this is for 4, this is for 5. Got it, right? So now who will come first? Tell me, if I am using this, who will come first? 0, horse. Then who will come second? Tiger, because 1. Then lion. Then your 2, cat. Then dog will come. Dog will come at last. Why? Because his number of leg is the most. 90 number of legs are there. Okay. So let's try to run this code. Who is coming last? Dog is coming last. Why? Because 90. Then cat. Cat is having 7. Then A is having, where is A? A is having 3. Got it, right? So based on this you have to sort it. Okay, so always when you use comparable and comparator, similar to this, I mean you can use comparable also and comparator also. Okay, so I will finish here only. I have to rush. Okay, tomorrow also, I mean tomorrow we'll see Bandi is there or not. Okay, I doubt tomorrow.